Hi guys, it's Mrs. Jaqua. It's our lovely webinar. Today we're going to be doing some cool things like dot product and vector projection. And it's going to be pretty cool, so let's get started. Push pause and read. It's pretty funny. It's funny. It is funny. Okay, the quarter ends May 21st, but let's remind ourselves that for the seniors, it's May 15th. Graduation is the 16th. Okay, so push pause and read this, and otherwise I'm going to be doing the math around it for the dot product. Okay, if we find the dot product and we happen to get 0, then we know that the two vectors are perpendicular and not otherwise. Okay, so let's find the dot product. The way that I like to set these up is I'm simply going to set them on top of each other. 3, -2, -5, 1. And then you just simply multiply to get -15 plus multiply -2. So the dot product is -17. Cool. Oh, that was like weird. There, stay. All right, so let's look at the dot product for this next one. So I have -2, comma -3, 9, comma -6. And we're going to use the dot product where you multiply the first two together. It's positive 8. Just kidding, it's not a positive 18. Back, 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 back. -18. Plus, that's a positive 18. You add them together, you get 0. So these ones are orthogonal. Orthogonal pretty much means that they're perpendicular, 90 degrees. All right, cool. So push pause, they have similar properties to our real numbers. They're commutative, they're distributed properties, scalar multiplication, all kinds of good stuff. All right, so what I want you to do is you can push pause and read through this. But I'm going to work these two problems like that one. And the sneak route is actually just doing that. So I'm going to do that. So I'm going to have the square root 12 squared plus 16 squared, which is the square root of 144 plus 256 equals square root 400 equals 20. So that would be the magnitude. Remember, magnitude and distance are a very similar concept. So we're working on this one, so we're going to do square root -1 whole thing squared plus -7 whole thing squared. Square root 1 plus 49 equals square root 50, which then becomes square root 25 times 2. So square root of 25, it's 5 square root 2. Sweet. All right, so now we could figure out the angle between two vectors. It's kind of cool. So notice my dot product is the numerator. And then these are my magnitudes. Okay, so let's go work some problems that look like that. Alrighty, so that's going to take a little bit of space. Let's get her done. Okay. Dot product of -5 and -2. Dot 4 and 4. Okay, so this is this component. And that's going to be -20 plus -8. So that equals -28. Okay, now let's do this component. with the square root of negative 5 squared plus negative 2 squared times the square root 4 squared plus 4 squared. So this is going to be square root 29 times square root of 32. So now we want to find the cosine of that. Now in our calculators, so our fraction so far is cosine theta equals negative 28 over square root, we'll put them together, 29 times 32. Now if we want to find the inverse of this, then we do cosine. If we want to find what the angle is, negative 1, plug this stuff in, negative 28 square root 29 times 32 equals, let's go to Desmos calculator. Oh, I don't want to do that. Now when we do Desmos, make sure that you go and make sure that it says degrees, otherwise you don't get a degree answer. Go to functions, go to arc cosine, because that means inverse of cosine, negative 10 divided by square root 29 times 32. So it's approximately 109. Oh, and it says to the 10th degree. 0.2. Alright, I gotta undo that because I didn't write it small f. Okay, so let's look at our vectors though. Let's see if they're for real. Our u vector is at negative 5, 1, 2, 3, 4, 5, down 2. So that's our u vector. Our v vector is at 4, 4, and that would be 109.2 degrees. Oh, you didn't even get to see that. How embarrassing. Okay, so that would be, I drew my u vector, my v vector was blue, my u vector was v, and then the angle is 109.2 between them. Sweet. Let's do that again. I don't want to do it again. Let's do the next problem. Okay, so push pause, we're talking about projection. The way that we use these ones are actually in physics when we start talking about forces and work force and friction forces and gravitational forces and all kinds of stuff. So memorize this. Alright, you don't have to memorize it, but these are ideas that I'm looking at. So let's go work at the next problem, and it takes a little bit of work. So if you want to write this one down for your notes and then push pause, well, push pause and write this down in your notes, and then the next thing I'm going to do is work a problem that's like it. Okay, so we're going to find the projection of u onto v. So the way that we write this, the first things that we have is we have u equals w1 plus w2. And then we know that w1 equals the projection of u onto v. Okay, and going off of our nifty-wifty formula from the slide before, this is how we're going to figure out our projection. Now the next thing that they want us to do is they also want us to write the sum of two orthogonal vectors, which are the two w vectors. This is w1 plus w2. And we'll show you how to do both of them. So we're going to need to go to the other board and do our work and then transport everything over. Sweet. So let's first figure out what w1 equals, the projection. w1, let's go write that formula down so we can put the stuff in there, equals projection of u onto v, u dot v magnitude of v squared times v. Okay, so now I just put it down there so I have it to work with. So we're going to put our parts in there. Vector u is 1, 2. And we need to put the dot product in there. Dot 8, 5. All over the magnitude of vector v, whole thing squared. Vector v is 8 squared plus 5 squared. And then we're going to times it all by vector v, which is 8, 5. Okay, so when we do the dot product, we're simply multiply the parts. So this is going to be 8 plus 10 all over 64 plus 25, square it, it's going to be 89. Then we'll multiply that by vector v, and that's going to equal, so this becomes 18. 18 times 8 is 'll make sure I did these problems right. Okay, 18 times 8 is going to be 144 over 89, and 5 times 18 is 90 over 89, and that's my first work one. So let's go write that over here. W1 equals 144, so this is my projection, over 89, 90 over 89. Then my last step that I want to do, so this is my projection. And then my last step that I want to do is I want to find out what u, back up, back up, back up, and back up, u equals W1 plus W2, which is, we know what the first work vector is, 144 over 89, 90 over 89, plus, I'm going to have to go use the board to find W2. So you ready to find W2? We're going to need this up over here. W2. So we know that U equals W1 plus W2. We know what these parts are. This is 1, 2 equals 144 over 89, 90 over 89 plus W2. In order to solve for W2, we're just going to subtract these vectors. Now we want these vectors to have common denominators, so this is going to be 89 over 89, This is going to be 178 over 89. Got it. So when we subtract those vectors, we get negative 55 over 89, comma 88 over 89. And this equals W2. Okay, so with that knowledge, we're going to go ahead and put that over here. Negative 55, 89. And 90. So those are my two answers. And this is the sum. Those are the diagonal ones. Sweet. Okay, so when we are looking in 3D plane, pay attention. This is your x-axis. This is your y-axis. And this is your z-axis. If I were to make this stuff up, I would have picked the x to be the y and the y to be the x or something different. Anyway, don't forget that. So let's go ahead and let's graph these. So I'm going to go x backwards 3, 1, 2, 3. The y over backwards 4, 1, 2, 3, 4. 1, 2, 3, 4. And then up the z-axis, so 1, 2. And it's really hard to make these look like they are in 3D space, so that is the vector. Oh wait, not the vector, just the point. That's just a point. We have no vector there. If I would have had those things, then we'd be talking vector. We have no things, so that's where we're at. So let's go find our next point. Let's go over 3 on the x-axis. 1, 2, 3. Over 2 on the y-axis. 1, 2. And then down 3 on the z-axis. 1, 2, 3. So that's where a big old dot is. Alright, let's go over 5. 1, 2, 3, 4, 5 on the x-axis, down, back 4. And then down 1. And that would be my big old point. Cool. Okay, so when we look at find our distance between the parts, it's just real similar to Pythagorean's theorem. You change difference of y squared, z, x's, difference of x's, square it, difference of y, square it, difference of z, square it. Midpoint, you add the parts and you divide by 2. Okay, so let's go work a problem that's like that. I want to get this sucker off. Okay, so safety regulations require airplanes to be at least a half a mile apart when in the sky. So what is a half a mile apart? A full mile apart is 5,280, right? So a half a mile is 2640. Okay, because the numbers that they gave us are in feet. The planes flying from Cleveland are the coordinates of 300, 150, and 3,000, and 450, negative 250. I don't really know how that works. Anyway, some magic number in space where it's negative 250 and 28,000 feet. Okay, the two planes are in violation. Are the two planes in violation? So what we're going to do is we're going to look to see if we do the change in x's, square them, plus the change in y's, square them, plus the change in z's squared. And is that going to be less than 2640? Okay, so let's go work our stuff over here on the board so we have more space. Square root. Change in x's are, I'm going to have to set this up with you guys not seeing how I'm setting it up. So I need those numbers there. So 300 minus 450 squared plus 150 minus a negative, which ends up being plus 250 squared plus 30,000 minus 28,000. Okay, so then this becomes negative 150 squared plus 400 squared plus 2,000 squared, which then breaks down to 25,225,00, 225,00 plus, oh, you can see what I'm doing now, 225,00 plus 1,600 plus 4 and 6 zeros. And then you plug those all into calculator, and we get, what do we get? 2045.12 feet. So are they in violation? Are they less than that? And so we have 20, what was it, 2045? Is less than 2640. Therefore, violation. Okay, so for B, all we have to do is we just have to find the midpoint. So what's in between 300 and 400? Well, that's 375. What's in between negative 250 and 150? That's negative 50. And what's between 30,000 and 28,000? Well, it's 29,000. So that would be the midpoint. Cool. Alright, so we're talking about vectors in space. What I want you to recognize is the I goes with the X. The J goes with the Y. The K goes with the Z. Okay, so if I see something in vector form, I just pull off the first one as a kind of an X location, Y location, Z location. Ready? So here's my vector. So there's my negative 4. 1, 2, 3, 4 on the x-axis. Go over 2. 1, 2. Go down 3. 1, 2, 3. So there's my vector. Oops, I've got to put a blue vector so you can see the arrows, because the arrow's kind of important. Alrighty, and the point at the end. Something kind of pretty like that. It's hard to draw these in 3D space, by the way. Okay, so this can be a negative 1, right? A negative 3 and a 4. So I'm going to go backwards on my x, go backwards on my y. 1, 2, 3. And then go up on my z. 1, 2, 3. Now let's do a red vector to that point. So if we were kind of trace it, we'd go over 1. Okay. Anyway, those are how we locate those vectors. Okay, so when I have two vectors in 3D space, it's not very hard. This is your distance, dude. It's your distance, dude. Okay, and then we want to find, these are the changes in x's. Okay, and we're not going to do that problem. We would just find the component form of the magnitude. So this is the component form. And then we'll find the unit vector, which is that. So let's find AB first. And that's going to equal In between those is so b minus that one is going to be positive 1. 4 minus a negative 5 is going to be positive 9. And 2 minus a negative 5 is going to be 3. All right, so now we can find our unit vector. Change in x's, it's going to be the same. 1 squared plus 9 squared plus 3 squared. Well, that wasn't a very big 3. So this is going to be 1, 9, 3, all over square root of 81, 82, 91. Okay, and we don't like having irrational numbers in the denominator, so we're going to rationalize the denominator. And then our answer, our unit vector, will equal square root 91 over 91, comma, 9 square root 91 over 91, comma, 3 square root 91 over 91. Cool. We'll go ahead and work another problem like that. Oh wait, no, this is a different one. We're not going to do that problem, we're going to do this problem. Okay, so the way that I set up these problems are easy-ish, is I say, what is 3y? Well, 3y is going to be 9, so I'm working with this, negative 18, and 6. What is 3z? I'm working with z, negative 6, 0, 15. What is w times a negative 6? Equals a positive 6, negative 24, and a positive 24. Then you're just going to add them all down. So this is 9, negative 42. So when I wrote down wrong, this is a 24. 24. Hold on, I gotta get rid of this one. It's messing me up. So it's 24, 30, 45. And that would be our answer. Alright, guys. We'll see you next time.